Hello and welcome back to computer programming. So today we're going to talk about the second of three sorting algorithms, and primarily it's the selection sort. So again, you're going to see a similar, array of materials here. There's going to be another video you can watch that sort of visually illustrates what's happening. There's the picture, which again just shows the numbers in order, so it's not super useful. Look, they're in order. That's the goal, to get everything in order. There's the lab document, which is obviously going to be a little more useful, and then there's the files themselves. So let's start with the files. So again, open a new window, hit download. Okay, go to our downloads folder, right click, extract all. All right, and then I'm just going to clean up, so I'll delete the zip. I'm going to move this in my computer programming folder. And there it is, selection sort. All right, so once we get this open, again, it's going to have pretty much the same exact setup as the bubble sort. So you're going to see a bunch of arrays. 4 of them are commented out. 1 of them is currently active. There's going to be the standard loop that prints them out. You're going to write the code that implements the selection sort. Then you're going to print them back out. I mean, the code's already there to print them back out to make sure that it worked. All right, so if I run this now, it's just going to print it out twice. And obviously, it's not going to work because there's no code. All right, still not in order. But that's your job, is to try to write the code that's going to put it in order, this time implementing the selection sort algorithm. And again, you can test the different arrays just by commenting out one and making a different one active. Just make sure you don't have 2 of them active at the same time. That'll obviously cause issues. All right. So, same setup as last time, same general idea. Let's talk about the selection sort algorithm and how it works. All right. So this one works a little different than the bubble sort. Instead of doing lots of flips, it's going to be more about searching and then doing a flip at the end. And you'll see what I mean by that in a second. All right. So it's still going to involve loops, still going to involve nested loops. We're still going to be repeating a process over and over again. It's just the process is a little different. All right, so this time, here's how the process works. All right, we start by guessing the location of the smallest number. All right, and we always guess that the smallest number just happens to be at the start. We're basically hoping that we get lucky and the smallest number is at the start. And then we also keep track of the actual location of the smallest number. All right, so at the start, they're both just 0. We just say, all right, we're guessing that the smallest number is in location 0, and we're going to say that the actual location is 0. Right? Then we progress through and we say, all right, well, at location 1, there's a value that's smaller than the value at location 0. So I can update this location and say, hey, now I think the smallest number is at 5. All right? Notice I leave the guess at 0. My starting guess always stays the same. But then I keep going through and I say, all right, well, 50 is bigger than 5, so nothing there. And then I go through and say, oh, -2 is less than 5. So the smallest number is actually at location 3. All right? Then I check location 4 and I say, nope, that one's bigger. And then I check location 5 and I say, nope, that one's bigger. So once I reach the end of the array, I know which 2 values I'm going to swap. I'm going to swap my starting guess with the actual location of the smallest number. So I'm going to swap 0 and 3. I'm going to put a -2 here. I'm going to put a 23 here, and I've swapped those. So notice I didn't keep swapping as I worked my way through the array. I went through the array, I searched for things, and then when I got to the end of it, I made my swap at the end. All right. Then I go through and I repeat the process, but I now know that the smallest number is at the start. I've already done that. So I say, all right, well, I'm going to guess that the next smallest number is at location 1. And for right now, I'll say that the actual location of it is at 1. Right? Then I check 2. I'm like, nope, 2 is has a number that's bigger than 5, so we're good there. Then I check 3 and I say, nope, 3 has a number that's bigger than 5, so we're good there. Then I check 4 and I say, oh, the number at 4 is less than 5, So let me update this and say that the location of the actual smallest number is 4 at location 4. Right, then again, move forward and say, all right, let me check location 5. Is this number at location 5 less than the number at location -4? It's not. So I now know that this is the second smallest number. And then I can say, all right, I've reached the end of the array. So let me flip location 1 and location 4. And this becomes -1. And this becomes 5. And now I'm guaranteed that the first two numbers are in the right spots. Right? So now I go back and I say, all right, let me guess that the next smallest number is at location 2. And then I check location 3 and say, oh, nope, location 3 has a smaller number. So the actual gets updated to 3. And then I check location 4 and I say, nope, that's smaller still. So now the location gets updated to 4. And then I check location 5 and I'm like, nope, location 5's number is bigger. So leave that alone. And I know to swap 2 and 4. So this becomes 5. This becomes 50. And then I know the first 3 numbers are in order. Right? And then the process repeats again. I say, all right, now I'm going to guess that the next smallest number is at location 3. Right? And then I check location 4 and I say, nope, that's bigger. So I don't need to update anything. And then I check location 5 and I'm like, oh, nope, that one's no good. No good. That one's smaller. So let me update this to a 5. And then I say, all right, I reached the end of the array. So let me swap locations 3 and locations 5. This becomes a 10. This becomes a 23. And now I know that the first 4 are in order. All right. So I'm almost to the end here, but I still repeat the process. I say, all right, I'm going to guess that the smallest number is at 4. I then check 5 and I'm like, oh, nope, 5 is smaller. So let me actually update it to that. I reach the end of the array. I do my flip. All right, so this becomes 23. This becomes 50. And when I do that last flip, because there's only 2 numbers left, I know that the entire array is now in order. All right, so that's a selection sort. All right, unlike the bubble sort, it doesn't keep flipping over and over and over again. All right, again, it starts by saying, let me just kind of run through it once from the beginning. I'm not going to run through the whole thing again. But it basically starts by saying, all right, I think the smallest number is at location 0. Let me go through and check to see if I'm right. Oh, nope, there's a smaller number at 1. 2, that's bigger. Oh, there's an even smaller number at 3. Let me update that. Nope, the number at 4 is bigger. The number at 5 is bigger. I've reached the end, so now I know that I'm supposed to flip 0 and 3 here. And if I do that over and over and over again, eventually, whoops, hoping to redo it and have it all go back, but it doesn't look like that's going to work. Eventually, if you do that over and over and over again, whoops, now I've lost my formatting. See, this is the dangers of undo. If I do that over and over and over again, eventually I will end up with my array in the correct order, just like I want it to be. All right, this one's going to flip -1, 5. Then this is going to flip 5 and 50. And this is going to flip 10 and 23. And then this is going to flip 23 and 50. And the whole thing is going to be organized. All right. But again, it does it via these variables that keep track of your start and guess, which just always goes up by 1 each time through the loop. And then you search through the loop to find where the smallest number actually is. And then you flip those 2 locations. All right. So we're not storing the values of our guesses and our locations and our actuals. We're storing like the locations of them so that when we get to the end of the array, we know which 2 locations to swap. All right. And that's, again, the selection sort algorithm. So if we look at the lab, again, same kind of general, it's going to walk you through some examples. There's a link if you want to look at another like visualization of it. It sort of describes what I just walked through. And then there's this advice section that says you're going to need to make use of nested loops again. You need a variable to keep track of the position of the smallest element. All right, that's kind of what I was demoing here. And your outer loop should only have to run n-1 times because when you get to the last number, it has to be in the right spot. That was that like final flip that I did. Once you get to that final one, you know it's in the right spot. So if there's 6 numbers, your outer loop only needs to run 5 times for it to work correctly. All right. So again, this is what you're trying to implement. Same as before. There are hints, but I would recommend you to try to figure it out on your own first. But if you're stuck, you can kind of use this as a guide to help you figure it out. The one piece of advice I will give you, because a lot of times kids confuse this with the bubble sort, is you are not swapping until you finish your inner loop. All right, so there should be no swaps inside of your inner loop. The swap should happen after you exit, or the flip should happen after you exit that inner loop, but before you go back up to the top of your outer loop. All right, that's kind of what I was trying to demo here, is that you go through and you search again and again and again and again, but you only flip once at the end. So, I search through the array and say, oh, the smallest number is at location 3. It's only when I'm done searching through the array, aka the inner loop finishes, that I actually make the flip of these 2 locations and say, okay, the -2 goes here and the 23 goes here. All right. A lot of times kids try to do their flip inside of that inner loop, and that's making it much more like a bubble sort. Right. This is really about not flipping until you get out of that inner loop, and instead recording the locations of those numbers so you know what to flip at the very end. Right. So hopefully this was helpful. Between this and the hints and everything else, you should be in pretty good shape to get this working. But if you have any other questions, obviously, just reach out and let me know. All right. Have a great day.